Good day all of you. Today's gate question is, in the circuit shown below, all components are ideal, input voltage is sinusoidal, magnitude of steady state output V0 is how much? Okay, this is a circuit given and they mention all the components are ideal. Okay, here ideal condition is applied for diodes. Ideal means reverse bias. In the reverse bias there is no current, and ideal means their cut-in voltage is 0. Okay, and ideal means when the diodes are in forward bias acts as short, and when the diodes are in reverse bias acts as open. Okay, yes. Now, so if you observe this very simple problem, very simple solution. Say this part of the circuit, this part, yes, let be the first part and this be the second part. Second part. Let us speak about the first part. First part of the circuit. The first part of the circuit is nothing but clamper circuit. Clamper circuit. What is clamper? It clamps the voltage. Okay? In a simple understanding way, it inserts DC voltage. It inserts DC voltage. Okay? Means, suppose if your input is like this, yes, let this be your input, Vi. Okay, let your peaks as Vm and minus Vm. When you apply this signal to this clamper circuit, what is the output? This is input and this will produce the output. This is the output. Okay, this is Vm and this is 2 Vm. Yes, why this is called, see here, why this is called DC? It inserts DC voltage means it is called DC inserter. DC inserter. See here, for this signal, as the signal is symmetrical about the zero line, what about DC? DC is 0. DC voltage is 0. But when this signal is applied to the clamper circuit, then the clamper output is like this. Means the signal is simply shifted upwards. So this is the output signal. What is the DC value here? You assume a center line like this. This value is nothing but your DC. Okay. So that is the reason it is called DC inserter. Suppose if the diode is reversed, means if the diode is like this, then the same signal gets shifted below the zero line, So when the signal is shifted upwards, the clamper is called positive clamper. And when the signal is shifted below the zero line, it is called negative clamper because it is inserting negative DC. Okay. So this is the output of your clamper circuit. Okay, now this clamper circuit output is given to the second part. Now what is the second part? Second part circuit is actually peak detector. It is peak detector. Now you are applying this 2 Vm signal at this part. Here you are applying a 2 Vm signal like this. This is your 2 Vm signal. Now for the 2 Vm signal, all see the voltage, entire signal is positive. So as the entire signal is positive, what will happen to the diode? Diode is always in forward bias because the diode is ideal. So when the diode is ideal and all the time when the diode is in forward bias, it acts as short. So the same signal or the same current goes to the capacitor. Now the capacitor will charge. Yes, diode is in on condition for entire signal. Okay. Now the capacitor will charge. Yes. To how much? Capacitor will charge up to 2 Vm. Up to 2 Vm. Okay. Yes. Now voltage across the capacitor is 2 Vm. Yes. Now when suppose take this first cycle. For the first cycle diode is on and capacitor will charge to 2 Vm. Now even for the next cycles, as the voltage is positive, diode is always an on condition to act as short, so the capacitor won't discharge. When the capacitor will discharge, when there is no current through the capacitor will discharge. But continuously your diode D2 is in on condition. Means continuously for the capacitor there exists current. Means continuously the capacitor is in charging mode only, means the voltage across the capacitor always remains at 2 Vm. Okay, so what is V naught now? V naught is nothing but 2 Vm. This is nothing but your steady state output. Okay, so here, yes, Vrms is given. So Vrms is equal to Vm by root 2 for full cycle. So Vm is Vrms into root 2. Okay, 2 into 230 into root 2. Yes, it is 650.4 volts. Okay, so the answer is 650.4 volts. Okay, so I think you understand this, the meaning of peak detector, because here the peak is, what is the peak value here? The peak value is 2 Vm. Okay, yes. The output is always at 2 Vm, hence this is called peak detector. Yes, it is detecting the peak value 2 Vm, hence it is called peak detector. Okay.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.